everyone, it's Mrs. Gandro again, and I am back with some more scientific notation. But today we're going to be talking about adding numbers in scientific notation and what all of that means. And really, who's going to be using adding numbers in scientific notation? Well, I can tell you right now, scientists do anything having to do with space, and you all know that I love space. Like, I really want to go to space one day. And anything having to do with nanotechnology or anything with large numbers or small numbers, we can add them together. So tonight's objective is we want to be able to add numbers written in scientific notation given real-world problems and scenarios. So let's check it out. So adding numbers in scientific notation, remember there are two parts to a number written in scientific notation. We have the powers, which if you take a look are right here. We have powers of 10. And if we take a look, we have our coefficients. And I'm going to underline those coefficients. Those are our first factors. So we have powers of 10 and we have our first factors. And we have to keep in mind that our powers are going to matter, especially when we're adding with scientific notation. So when we add numbers in scientific notation, we need to follow a couple of important steps here. First of all, we're going to check to make sure that we have our adding symbol. So we are adding. And so the first thing we do is we check to make sure that we have the same power of 10. So I'm looking over here, I have 10 to the fourth and I have a 10 to the fourth, so that's a check. We have the same power of 10. And if we don't, well, we're going to learn about that in just a little bit, what we need to do when we don't. But right now we do have the same power of 10. So I'm going to take a look at my coefficients. Yes, that's a great mathematics vocabulary word, coefficient. Those are the numbers out front of the power. So we're going to add those numbers, 6 plus 2, and that is going to give me 8. So 6 plus 2 is 8. And then the third step we have is we're going to write our answer with our new coefficient in the same power of 10. So I know that 6 plus 2 is 8. So I have 8 plus, oh, sorry, it's not a plus. We're actually going to erase that, and we're going to make it a times. So 8 times 10 to the fourth power. 8 times 10 to the fourth power, and voila, that's our answer. So now it's really important for us to check our work. So we started off with 6 times 10 to the fourth plus 2 times 10 to the fourth, and we figured that it was 8 times 10 to the fourth. Well, we can check it by writing it out in standard form. So I know that 6 times 10 to the fourth is 60,000 because it's 6 times 10 times 10 times 10 times 10. And that gives me 60,000. And the same thing for the 20,000. That's 2 times 10 times 10 times 10 times 10. And I know that 8 times 10 to the fourth is going to be 8 times 10 times 10 times 10 times 10. And I'm going to give you a little hint. The power here tells you how many zeros that we have to have. So since I have a power of 4, I have 4 zeros on the back side of that. So does 20,000 plus 60,000 equal 80,000? Well, I'm pretty sure that it does. And the answer is yes. So let's take a look at writing that in scientific notation. Remember, my factor has to be a number that is greater than or equal to 1 and less than 10. So I'm going to take this decimal point that's right here, and I'm going to go 1, 2, 3, 4, and I have 8 times 10, and I move that decimal place 4 places, so 8 times 10 to the fourth. So it does work out. Awesome. So let's take a look at what happens if our numbers that are written in scientific notation don't have the same power of 10. And you know what? This happens a lot more often than what you think. So let's take a look at this word problem. A dust mite has a length of 2.5 times 10 to the fourth meters. A beetle has a length of 3.1 times 10 to the negative third meters. What are the combined lengths of a beetle and dust mite? So the second time I read it through, I'm underlining my key important information here. the dust mite that has a length of 2.5 times 10 to the negative 4th meter, and my beetle that has 3.1 times 10 to the negative 3rd meters, and it's talking about combined lengths. Well, this is an important key vocabulary word because combined means that we are going to add, subtract, multiply, or divide, and we are going to be adding. So, let's take a look at this. I know that I have 3.1 times 10 to the negative 3rd, and I'm adding to that 2.5 times 10 to the negative 4th. You can also look at it as 2.5 times 10 to the negative 4th plus 3.1 times 10 to the negative 3. That's totally fine. But the important thing here is check out my powers of 10. I have 10 to the negative 3rd, and I have a 10 to the negative 4th, and they are not the same powers. So we're going to make an adjustment here. So recall that when we move the decimal point to the right, we subtract powers of 10, and when we move the decimal point to the left, we add the powers of 10. So the important thing is we have to have the same powers of 10. We have to have the same powers of 10 here. So I always look at this as it's easier to increase. So it's easier to increase the power of 10. So let's take a look. I have 3.1 times 10 to the 3rd plus 2.5 times 10 to the negative 4th. Well, if I take a look here, this is the smaller power. So I'm going to bump that up by how many places? 1. So I'm going to move this decimal point 1 place to the left. So that means I'm going to be adding on 1 power. So this is negative 4 plus 1. And that's going to give me 0.25 times 10 to the negative 3rd power. So I'm going to take this decimal and move it 1 place this way. Just like that. So now I have the same powers. Now I have my power of 10, 10 to the negative 3rd, 10 to the negative 3rd. I can go right ahead and I can add these together. So off to the side, I know that 3.1 plus 0.25, I'm lining up my decimals here, is 3.35. And then I'm going to keep that power of 10. So times 10 to the negative 3rd. So my final answer is 3.35 times 10 to the negative 3rd longer. And so, of course, we should always check it out. So let's go ahead and check it out. And I'm going to erase this right here so this is a little bit more clear for us to see. So if you take a look, I'm going to go ahead and write this in standard form. 3.1 times 10 to the negative 3rd is 0.0031. And 2.5 times 10 to the negative 4th is 0.00025. And if you don't believe me, we can just move it. And 1, 2, 3. We add those together. Now let's go ahead and convert them back into scientific notation. Starting with my decimal point that's right here, I'm going to move it back 1, 2, 3 places. Since I'm moving backwards, that's going to tell me that I have a negative exponent. Since I moved back 3, that's where I get my negative 3 from. So I think it's time for you to practice some on your own. So I have 3 practice problems here for you. One is a word problem. So I'm going to give you a few seconds here. Pause the video, check these out, and then come back and let's see what we did. All right, so hopefully you paused the video. And the cool thing about this first one here, we have 1200 plus 9.9 times 10 to the 3rd. Well, I'm really not liking this format, so I'm going to convert 1200 into scientific notation. So 1, 2, 3. This is 1.2 times 10 to the 3rd power plus 9.9 times 10 to the 3rd power. Adding my coefficients here, adding my first factors, 1.2 plus 9.9. That gives me 11.1. So my answer is 11.1 times 10 to the third power. Or is it? Well, let's take a look at this, because if we take a look here, this is not written in proper scientific notation. So in order to do that, I need to bump this up one place. So 1.11, and since I'm moving forward one place, I have to add on 1 power of 10. So this is 1.11 times 10 to the fourth as my final answer. Remember your LA notebook, left we add, and there's our answer. Awesome. So let's take a look at the next one. So if I look over here, the first thing I'm noticing is that I don't have the same powers of 10. And remember I said it's easier to increase the smaller power. So this is my smaller power. I'm going to increase that by 3. So I'm going to move my decimal place by 3. Why am I increasing by 3? Because this is a power of 8, and 5 plus 3 is 8. So I have 0.0023 times 10 to the fifth plus 2.12 times 10 to the eighth. Adding that together, lining up my decimal points. So I'm going to do that right here. That gives me 2.1223, and since I increase this by 3, 5 plus 3 gives me the 10 to the 8th power. So my answer is 2.1223 times 10 to the 8th power. And let's check it out. Oops, I'm going to go back one. Oops, I've skipped ahead a slide here. So let's go back a slide. Okay, so my final answer should be not there. 2.1223 times 10 to the 8th. So now let's take a look at the final one. Sorry about that mix-up there. It says the mass of the moon is about 7.3 times 10 to the 22 kilograms. The mass of the Earth is 5.9 times 10 to the 24 kilograms. And Pluto is 1.3 times 10 to the 22 kilograms. So it says find the combined mass of the moon, Earth, and Pluto. So taking a look here, combined means I am going to add, subtract, multiply, or divide. Well, we are going to add these all together. So adding 7.3 times 10 to the 22nd plus 1.3 times 10 to the 22nd plus 5.9 times 10 to the 24. Well, this is all great except for one thing. I don't have the same powers here. So I need to convert my 22s into 24s. Remember, it's easier to make the smaller power of 10 a larger one. So I'm going to do that by moving the decimal point 2 places. Why 2 places? Because 22 plus 2 is 24. So this is 0.073 times 10 to the 24th. 2 places here, plus 0.013 times 10 to the 24th, plus 5.9 times 10 to the 24th. Adding all of those numbers together, 0.073, 0.013, keeping my decimal points in line, and 5.9. This gives me 5.986, and I've got to tack on my power here, so my final answer is 5.986 times 10 to the 24th. Okay, so hopefully you practice enough, and we're going to be talking about this a little bit more tomorrow in class, but our focus question, this is the question we want you to think a little bit about, is what are the most important factors when adding numbers in scientific notation? So I want you to think about this one. So there's probably a couple of things that we need to think about when we add numbers in scientific notation. Thank you for being an awesome audience tonight, and I will see you all tomorrow. Have a fabulous night. Bye.